Hey guys, I'm Pat Kelly. Okay, in this problem, they ask us to evaluate the definite integral, and then, as if we had any doubt, we're supposed to verify our results using a graphing utility. So you might want to have one of those handy. Okay, to jump in and start doing it by hand, I might not like the look of that integral at first, but I'm going to do a quick u substitution. And have you noticed how much u substitution saves the day? Remember way back when you first learned it? U equals, I'm going to go up to a minus x squared here. And so du equals minus 2x dx. And then when I substitute back into my original integral, this integral now equals, I've got my x dx that's going to become du. All I really have to worry about is that constant factor of a minus 2, which is not an issue. Constant factor is never an issue. I'll bring it out in front, and it'll actually be a minus 1/2. The integral, the x and the dx go to the du, so all that's left is the e raised to the u du. And if you remember with your u substitution, you have two choices with those limits of integration. One was either to keep them as x values and resubstitute later, or the second option maybe is to convert those x values to u values, and I'm going to go with that option. So if x equals 0, u equals 0. When x equals 1, u equals a negative 1. And that becomes a much friendlier integral. That's the point with u substitution. It really saves the day very often. Okay, so now I'm looking to integrate just this e to the u du. And that's really, I guess, the new material in this section, right? But if you have learned your integrals of these exponential expressions, that's actually just going to be e to the u again. Okay, so let's go down to the next line. This equals, I still have my minus 1/2, but e to the u integrates to e to the u. That's the new material, but the easiest part of this problem. So that's kind of cool. And I do have these limits of integration. I want to make sure I evaluate this from 0 to a minus 1. Okay, so let's plug those in. This equals, still have my minus 1/2 out in front. E raised to the u, plugging in a minus 1, so let's maybe even write that as 1 over just e to the 1 power. Subtract what happens when I plug in a 0. E to the 0 power is always 1, so I'm just subtracting 1. Okay, and that looks pretty good right now. I might distribute through the minus 1/2. Let me slip down. Equals, if I distribute through the minus 1/2, I'd probably even rearrange the order of the subtraction to make the leading term positive. Like that. And I'd actually be happy with that in terms of a final answer and simplifying as much as possible. You could go further if you wanted to make it one fraction. I don't think we'd really need to. But what I will do is go one step further and grab a calculator, only because I'm anticipating trying to verify this result with my graphing utility. So let's look at the decimal approximation of this. Okay, so I'll grab my graphing utility, or even just a calculator at this point, because we're just doing some number crunching. But I'm going to do a 1/2 subtract 1 divided by 2 times e raised to just the 1 power. And my decimal approximation is 0.316. Okay, great. Pat yourself on your back for that answer that you got on your own. And the second part of the direction said to verify using a graphing utility. So whatever your graphing utility of choice is, grab that. And what you need to do, of course, with these integrals is go to that integrand, the expression on the inside, and that's your y equals, right? You're just putting this part in for your y equals x times e raised to the minus x squared power. I'll graph that. Depending on your settings right now for your window, you might want to zoom in. I'm going to zoom in once. I can see what's going on just a little bit better. But then to really confirm the value that we got, doing it our way, I now want to use the calculus features of my graphing utility to find that integral from 0 to 1. So bring that up in whatever menu you need to. Find your integral features. Start with a lower limit of 0, upper limit of 1. It thinks for a little bit, but it comes up with the same 0.316 that we did. So that makes you feel pretty good, right? Okay, use that knowledge hopefully for some of the other problems. Go try some on your own, okay?